Hello, welcome everyone to question number 14, number of leaf nodes. From the topic tree in Geek for Geeks must do interview coding questions. Have a quick look at the question. I will be discussing the meaning and approach to it. Before that, please don't forget to hit the subscribe button, and if you have any doubts, just leave a comment down below. And also if you have any extra email IDs, please do subscribe our channel for contributing towards the growth. And now let's know the meaning of the question. Here the question is saying that we have to find the number of leaf nodes. So we have to know what are leaf nodes first. So what are leaf nodes? So carefully see here the end of the sub tree, or you can say it is a left subtree. Okay, this is a left of left subtree. This is right of left subtree, and this is right of right subtree, right? So the last elements visually we can say these are leaf elements. But if you give a technical answer, we could say wherever there are elements which doesn't have child elements, right? This is the last node. How do we know that's the last node? Because we don't have any child elements to it, right? 3, there is no left subtree, there is no right subtree. For 5, there is no left subtree and right subtree. Similarly, for 1, there is no subtree for left and right both. Okay. But if you see the other elements, there is a left subtree present or the right subtree present, or both of them are there. So leaf element are only those elements which doesn't have child nodes. Okay, those elements are considered as leaf. In this case, you can see clearly 3 doesn't have, 5 doesn't have, and 1 doesn't have any child node. So 1 plus 1 plus 1, which is 3, that is the output that we have got. Now we have understood what are the leaf nodes and the technical answer what can be a leaf node. Now let's go into the approach and how can we deal it in a coding manner. Now after knowing what are the child nodes, we can implement a logic here. Okay, whenever we get left subtree, okay, left subtree and right subtree element as none, we return one as the answer. And every time there is a condition left and right is there where the nodes are none, we return one and add to the previous value. So this one will be acted as left subtree and this one will be acted as right subtree. Okay, logically if we want to do a dry run, you can see here 7 left subtree, it is there, right subtree it is not there, so this condition won't satisfy. Although conditions only satisfy leaf points, right? Now we came to 3 here. Okay, the left subtree is none and right subtree is none, right? Now we return 1. Similarly for the right subtree, this subtree, this part, in this also we have left subtree and right subtree here also. From in this left subtree, we have one element where child nodes are not there. So we add 1 there again. Okay, we add 1 again for the one element present here. This is used in recursion approach. Here we get one value and we add each time that one value. Okay, I hope you have understood what is a leaf node and also the logic behind the logic behind that we are going to add one each time where left and right subtree nodes are none. Okay, we add one each time. So this is the logic behind the question. We still haven't understood, let's go into the coding part and it will be very much clear there. Now we are inside the coding part in the Geek for Geeks website here, and I have already implemented the code for you. If root is none, we return 0. And the other condition is root dot left. Okay, root dot left, root dot right is none, which is at the last point here. You can see in the left side here, if we reach the at the fifth element, the fifth element will be treated as root here, which is not none, right? Fifth is not none, so it won't return 0 here. But root dot left side of this, and root dot right side of the fifth element is none, so it will return 1 here. Okay, now 1 has been returned here for the root dot left of the element 10, and root dot right of the element 10 is none here. See, root is none, we return 0. So 1 plus 0 is 1 here, right? That is the important of 0 here. If root is none, we return 0 and we can terminate the recursion there. Okay. And this is not the only recursion here. Okay, we can visualize, we can take root dot left of this one and root dot left of this one. Okay, Now we taking root dot left here and root dot right here. We haven't taken root dot left and right of this 39 element. And there will be one more root dot left here, right? Root dot left of this one is none and root dot right of this one is also none. So in this case, what happens is we return 1 again here, okay, for this element. So 1 plus 1 will be 2 here. Now we are inside the Geek for Geeks website here, and as you can see, whenever the root is none, we return 0. And the only condition that which is very important, if root dot left and root dot right is none, like at this point 5 here, root dot left and root dot right is none here, we return 1. Okay, and every time such condition comes, we add here, we add in the return part, okay, in the else part. Okay, at the final answer we will be getting the output 2 for this example. I hope you have understood the question and also the logic behind it. If you like the video, please give us a like and also subscribe to our channel. And if you have an extra email ID, please do subscribe with those, which is very important for the growth of our channel. And thank you for watching till then. Let's meet in another question.